Good morning, Algebra. For today's lesson, there's not going to be pre-video or anything. It's just going to be straight to it. We're going to be working through day 4 stations. I just need you to do each of those problems, and I'll explain a few things along the way. Okay? So for starters, let me turn on the light here. We're going to be setting up equations, exponential equations for growth and for decay. But before we get started with that, please make sure that you're asking questions through the Google Classroom comments section. I can't stress that enough. Apparently, there are still people asking questions through the private message section. No, that goes into a email account that has like 100,000 emails in it. Every time any of you do anything on Google Classroom, it sends you a message. So if you're sending private messages there, please stop. Go to Google Classroom. Go to the most recent post and add a Google Classroom question there. Also, I still have some of you who are not doing your Google Classroom questions. You gotta still do those. That's part of the assignment. And then there's going to be one extra one every Thursday. The Thursday one is already posted. And then if you have any questions about the previous lessons, hopefully I can explain them now. All right. So let's get started. I think there's 16 problems. Let me check real quick. 16. Yes, we have 15 plus 1, and that last one's a graph. And I'll explain how to do that in your calculator. Okay. Station 1, number 1. It says, oh, by the way, if you're looking at Google Word documents inside of the Google Classroom previewer, sometimes you won't get the entire equation. You got to download that thing all the way and then view it. I hope that answers most questions and answers most issues. All right, number 1. It says a loan for $10,000 has a compounded interest rate of 0.5%. Write an exponential function to represent the amount owed on the loan A after T years if no payments are made. So, for starters, we're going to go over what is the exponential function. It is y or f of x. Anytime it says write an exponential function, we're going to use f of x. If it says equation, we're going to use y. All right. So we have a, which is the initial amount. We covered that in the notes the other day, times b. And b represents 1 plus the rate or 1 minus the rate. Plus is for growth. Minus is for decay. And then you remember that rate is the decimal form. In decimal form, if you do the percentage, it will be wrong. Always decimal form. Yeah. All right. And then to the power of t, which is time. We can also replace that with an x. Either way, it's the same thing. We're just putting the number of years or weeks or whatever amount of time that they're talking about. So problem number 1 says a loan for $10,000 has compound interest. So we know that the initial amount was $10,000. So f of x is equal to 10,000 times, let's see, a loan compound interest. We know that it's going to be compounded interest. So it's going up. And so we know that is 1 plus. Our rate is 0.5%. 0.5%, when we change it to decimal form, is actually 0.005. So 1 plus 0.005 to the power of t. All right, for an exponential function to represent the amount owed on a loan A after T years if no payments are made. Now, the only thing we need to do to this is we need to change the inside. We need one value in there for B. Okay, so we need to simplify that area. So we change this to f of x is equal to 10,000 times 1.005 to the power of T. And that would be your final answer. There's no hint at how many years. This works for all the years. If no payments are made, do you see where it says that? once again, this is a loan, so it's getting bigger if you don't pay it. All right. So no payments, meaning no subtraction, no nothing like that. Nothing's changing. All right. Number 2, $1,000 is deposited into an account that earns is the implication there. That is the growth word in the whole formula or in the whole equation here. So $1,000, we have f of x equals $1,000. And then it says earned, so we know it's 1 plus for growth. So 3% changes to 0.03. And it says with an interest each year, write an exponential function for t years if no money is taken out. So we're back to that t right here. And of course, the only thing you need to do to correct all this is to simplify for b. So it's going to say 1.03 to the power of t. All right. Number 2. So we're not finding any answers just yet. We're just writing equations. Number 3. Number 3 says a student took out a loan for $5,000, so f of x is equal to 5,000. Remember, this is your initial amount, however much you took out, however much you borrowed, all that good stuff. And plans to pay off half the amount owed each year. Half the amount owed each year. So if this is paying off or decaying, we're going to go by half each year. So what is that? I hope you said 50%. Half each year, 50%. So we changed that to a decimal, and it is 0.5. So we said that this is decay because he's paying it off. 0.5 to the power of t, and then it says the amount of remaining to be paid off after t years. All we need to do is simplify here. F of x is equal to 5,000 times 0.5 to the power of t, because 1 minus 0.5 is 0.5. All right, remember, every time it's decay, except for that special case scenario, whenever this is negative, whenever it's decay, it's always going to be less than 1. Whenever it's growth, it's always going to be more than 1. All right, number 4. Number 4 says population of Winnemucca, Nevada, I don't know how to say that, can be modeled by P equals 6,191 times 1.04 t, where t is the number of years since 1990. What was the population in 1990? Well, if it's since 1990, we know that the population in 1990 was the original population. Okay. And then it says by what percent did the population increase each year? So we're looking for R. We know that is going to have R inside of it. We know that it was growth, so it's going to be 1 plus R equals 1.04. 1.04. So we're going to subtract 1 on both sides, and we're going to get R equals 0.04. And we're going to change that into a percent, so we're going to move it to the right 2 times and get 4%. That is our R, is 4%. So for the first answer, what was the population in 1990? It was 6,191 people. And for our second answer, it is going to be 4%. By what percent did the population increase each year? All right. Number 5. Number 5 says, the wise man asks for 1 grain of rice today and triple each day that follows. Write an exponential function to represent the amount of rice he has, R, after t days. Okay. So the word triple in here, that's a very specific thing. Triple means to ignore all this. Triple means to grow, right? We're getting bigger. If I triple the amount of money in your pocket, it's increasing. Right? So if I triple here, we're ignoring the 1 plus, we're just putting in a 3. If I were to double something, I would ignore all this and put in a 2. If it was quadruple, I would ignore all this and I would put in a 4. Okay, so let's write the equation for this guy. Wise man once says, so write an exponential function. So f of x equals, how much did he ask for? At first, 1 grain of rice today, right? So 1 was our initial value, and we're tripling each day that follows it. And it's every day. That is our time every day. Okay? So how much rice does he have after R how much rice does he have R after T days? We're going to change this to an R because that's what it's requiring of us. And that's it. So we have, that whole thing should be an R. R equals, and now do we need this bit of information? No, because 1 times anything is itself. So it's just 3 to the power of T. Okay? This is the total amount of rice. Remember, y or f of x is always our total. It says that R is the amount of rice he has, the total amount of rice that he has. Okay, so that's what we're getting to. All right, 6. Number 6 says that a certain bacteria doubles every hour. Right now there are 10. Write an exponential function to model the number of N bacteria after T hours. Same sort of thing. We have N bacteria instead of our f of x or our y. That's the total number of bacteria. It said we started off with 10 bacteria. All right. Right now there are 10 bacteria, so that's our initial amount. To double something is to multiply by 2, so we ignore the 1 plus the rate and all that stuff, 1 minus the rate, and we just put in a 2 because we're doubling. And we're talking about hours. It says T hours. T, remember, is just time in whatever form we're talking about. It could be years, it could be hours, it could be minutes. So one thing I would like you to do is go ahead and look at the wise man equation and go ahead and look at the bacteria equation and put them in your calculator and see how many grains of rice that man gets after 10 days, 15 days, 100 days, okay? I think you're going to notice something about that. That kind of follows along the, would you rather have $1 million now or a penny doubled every day for a month or a year or something like that? I think it might be a month. Number 7. Number 7 says, business made a profit of $35,000 in 2009. Write and solve the exponential function to find the profit in 2015 if it increased 20% each year. Round your answer to the nearest dollar. So now we're having to find solutions. So let's put this thing together. Let's figure out how many years we're talking about. Let's figure out how much the initial value is, and let's figure out the rate and if it's growth and all that. So it said it made $35,000 in profit in 2009. So that is our initial amount. F of x is equal to 35,000. And it says that if it increased, which means 1 plus, by 20%, if we change 20% to a decimal, it's 0.2. So 0.2 to the power of, now we have to figure out how many years this is going on. The original was in 2009. And they want to know about 2015. So I'm going to subtract those two numbers from each other, and I'm going to get 6. Okay, so we're going to put to the power of 6 here. Type that in your calculator. Type that in your calculator, 35,000 times, and then 1.2 or 1 plus 0.2, either one will work, to the power of 6. Hit enter, and we get 104,509.44. So remember, it says that you do need to round to the nearest dollar. So our final answer would be $104,509. Okay. All right, I'm going to go ahead and stop this video. I'm almost out of time on my 15-minute timer, and I'll start up another one.